One of the main features of the graphs of rational functions are asymptotes. And so we're going to learn about vertical asymptotes, horizontal asymptotes, and what are called oblique asymptotes. So the first thing we're going to learn how to find are the vertical asymptotes. So vertical asymptotes are a vertical line, and we say the line x equals a is a vertical asymptote for the graph f of x if the y values approach infinity or negative infinity from either the right or the left. So we see if we draw this dotted line right here at x equals 2, on either side, on one side the graph is going up toward infinity, and on the other side it's going down toward negative infinity. And so that the dotted line isn't actually part of our graph, but on either side the graph is approaching infinity or negative infinity, and that's called a vertical asymptote. So we say the vertical asymptote is the line x equals 2. And since we are talking about the equation of a line, that x equals part is important. Okay, now to actually find vertical asymptotes, these are going to be where our functions are undefined, or at least some of the places. So when the denominator is 0, and they don't have any other common factors, then you have a vertical asymptote. So what I'm saying is if you factor the numerator and the denominator, and if you have a factor in the denominator that doesn't cancel out with a factor in the numerator, then we have a vertical asymptote. Okay, so for number 5 here, we have f of x equals 2x plus 5 over x squared minus 2x minus 8. And let's go ahead and factor the denominator. It's going to factor as x minus 4 and x plus 2. Now these two factors, they don't cancel out with anything in the numerator, so we're going to set each factor equal to 0. X minus 4 equal to 0 and x plus 2 equal to 0. And these lines, x equals 4 and x equals negative 2, will be our vertical asymptotes. Okay, so vertical asymptotes really have to do with factors in the denominator that don't cancel out. Okay, for number 6 here, we have x minus 3 over x squared minus 1. Well, x squared minus 1 is a difference of squares. It factors into x plus 1 and x minus 1, and those don't cancel out with the x minus 3, so we would get x equals negative 1 and x equals 1 as our vertical asymptotes. And you should see a pattern here when we also talked about the domain. These are values that aren't in the domain. You don't have a y value there. Okay, and for 7 here, we have h of x equals x minus 1 over x cubed minus 5x. Well, the first thing we need to do, we can pull out an x, so that would be x times x squared minus 5. And then that would factor as x minus the square root of 5 and x plus the square root of 5. So we get 3 vertical asymptotes here, x equals 0, x equals the square root of 5, and x equals negative square root of 5. Okay? Now, one small example. Let's say you factored something and you had f of x equals x minus 1 over x minus 1 times x plus 2. Then we'll actually see in a few videos that this common factor, the one that could cancel out, doesn't give you a vertical asymptote. It'll give you what's called a whole. So in this case, our only vertical asymptote would be at x equals negative 2. So you just want to be careful. If things would cancel out completely, then you'll have a whole rather than a vertical asymptote.